Welcome back. I have discussed in my previous video neighborhood, interior point, open set, closed set, limit point, and this definition is stone of real analysis. At first, I recommended you recall this definition again. Now to continue further toward calculus, we need a concept called sequence. Let's start with what is sequence. What is sequence? What do you think one should be studying about sequence? Are the sequence around us? Yes. They are everywhere. You go and buy a ticket of something. What you are doing? In English, you will say you are forming a cube. But as a mathematician, you will say you are forming a sequence. Okay? There is order in cube. I am first, he is second, and you are the last. You go in the end. So, a sequence is just a collection of objects where there is an order in any object, first, second, third, which is called as a sequence. Okay? What is the definition of sequence in mathematics? A sequence is a function, okay, which a from n to r. How do you repeat a sequence? Sequence represent in following way. This is n belongs to natural number and this is fn, who is equal to the symbol which is taken as xn. Okay? Here n means natural number, so it will be 1, 2, 3, 4, so on. And here the value x1, x2, x3, x4, so on. A sequence is written as xn. Okay? Well, it is actually complete enumeration, right, to understand. It is not standard function, please, because here if I want to write the range of function, you take the repeated value. Okay, so it is actually complete enumeration. Let's see some example. A from natural number to r such that f of n equal to 1 over n. Then the sequence is xn equal to 1, 1 over 2, 1 over 3, 1 over 4, so on. Are you getting my point? Okay. This is a complete enumeration. Here no repetition. Let's see another more example. Fn equal to minus 1 to the power n. The sequence xn equal to one minus 1 1 minus 1 so on. Are you getting my point? And the range of the sequence here 1 minus 1. Okay, well, if we see other sequence Fn equal to n square, then the sequence will be xn equal to 1 4 9 so on. And what is the cardinality of the sequence? All of us know what is cardinality of any set. I have discussed in my previous video about countability, uncountability, cardinality, and I have given this link in my description box. So I recommended you, if you don't see the video about cardinality, please at first see this video, then it will be more clear. What is the cardinality of sequence? Every sequence has a cardinality with set of natural number, which is called arithmetic, which is given by George Cantor. Okay? Well, for choosing particular these three sequence obviously has some reason. Let's see nature of three sequence. First, xn equal to 1 over n. Okay? Thus, there exists any real number such that member of the sequence one over n are getting close to real number as n increases, are getting close to a real number as n increases. Okay? If you look just this sequence, you see the numerator is getting increasing as n increases. Okay? That means whole number 1 divided by that fellow is getting smaller and smaller. So it is clear it is very close to 0. And this kind of sequence is called convergent sequence. Okay? Here, this sequence is going towards 0. So limit xn as n tends to infinity, here will be 0. Okay, right. And look at that sequence. What is the limit? Here it is going to up and up. When the value increases, that means is goes to infinity. And here xn equal to n square, and limit xn as n tends to infinity, here infinity. And this is such sequence is called divergent sequence. Okay, this is called convergent sequence. Well, and this is just notion. We are going to elaborate next what is the definition of convergent sequence. Okay, if only the limiting value is finite, then the sequence is convergent, and otherwise it will be divergent sequence. Okay, but divergent sequence is two types. One type is if the value plus infinity or minus infinity, then this is also divergent, this same like. Otherwise, look the sequence. What is the limiting value? Here the range of the sequence plus 1 and minus 1. Here the limit xn does not exist. We cannot tell this sequence goes to any finite number. Okay, so such sequence is called oscillatory sequence. Right? Have you understood? Okay. Let's see convergent of a sequence. Intuitively, if a sequence close to any real number, unique real number, then the sequence is convergent sequence. But mathematically, what is the definition of the convergent sequence? Let xn be any arbitrary sequence. We say xn converges to L if following thing happen. Given any epsilon greater than 0, there exists capital N such that modulus of xn minus L strictly less than epsilon for all n greater than equal to n. Now, at first, we need to understand what is exactly mean this inequality. It means xn minus L strictly less than epsilon, that imply minus epsilon strictly less than xn minus L strictly less than epsilon. which also imply minus epsilon plus L strictly less than xn strictly less than L plus epsilon. That means xn lies L minus epsilon, L plus epsilon for all n greater than equal to n. Well, now look at the picture geometrically. Xn converts to L. What is the geometrical meaning? This is a real line. This is L. And if I choose epsilon distance here, then this will be L minus epsilon. And if I choose epsilon distance here also, this will be L plus epsilon. Okay? That means, what is definition? Given any epsilon strictly greater than 0, I have chosen in interval around this L. That means, what happened? By definition, there exists n such that n greater than equal to n, xn lies L minus epsilon, L plus epsilon. Okay? That means there exists capital N stage such that after this stage xn lies L minus epsilon, L plus epsilon. Geometrically, again let's see the clear expression xn converges to L. Again, what is meaning xn convergence to L? This is any real line and this is, let's choose this is L. Just choose arbitrary interval around L. Why here arbitrary? Because by definition, recall again, there is given any epsilon. For that, arbitrariness of length of interval we can choose. Then there exists n stage such that after this n stage all member which of the from xn plus p where p greater than 0 lies entirely in this region. Okay? This is the actual meaning of convergent sequence in mathematically. Alright? Okay. Now, let's come to see some example by definition of epsilon delta definition. Is the sequence convergent or not? Let's come back to example. First example, xn equal to 1 over n. Okay? Intuitively, it says 1 by n become close to 0. But by the definition of convergent, it still should happen that the sequence is converging to 0. That means here L equal to 0. And to prove L equal to 0, what we have to do? I have to find capital N such that for all n greater than equal to capital N, that imply modulus of xn minus 0 less than epsilon. That imply 1 over n minus 0 strictly less than epsilon. Okay? And I have to find such capital N. Here we can use Archimedean property? Notice my previous lecture. I have discussed what is Archimedean property. At first I recommended you please see this video about Archimedean property because Archimedean property is very useful for real analysis. After this video it will be so easy to understand. Okay? And I have given the video's link in my description box. By Archimedean property, given epsilon greater than 0, there exists capital N such that 1 over n strictly less than epsilon, and if n greater than equal to capital N, then 1 over n strictly less than 1 over n capital N, which by Archimedean property this is less than epsilon. Well, and this is true for all n greater than equal to n. That means I could find such states capital N. So after this states capital N, all term of the sequence is less than epsilon. Okay? So the sequence always converts to 0. Well, let's see other easy example. Xn equal to C, and this sequence is called constant sequence. Okay? Well, intuitively we can say this sequence converts to a number C. Okay? Let's check the definition of convergent. First are any epsilon greater than 0. Okay? Now we have to find capital N. That means for all n greater than equal to n, modulus of xn minus c strictly less than epsilon. This we have to show. Well, and this is obvious. Why? Because here all terms of the sequence xn equal to c, that imply c minus c equal to 0, which is always less than epsilon for all n greater than equal to n. This is our proof. Okay? Well, now I want to look back convergence of the sequence xn equal to minus 1 to the power n such that n belongs to natural number. Okay? Let's draw a picture. Here 0, here plus 1, here minus 1. What is the definition of the limit of a sequence? Take any small interval around the point which you think is going to be limit of the sequence, then after some stage all term of the sequence should be there. Then we have seen this is not happened here. Let's see. If I choose 1 be limit point, then take any small interval around the point 1, then minus 1 cannot be attained in this interval. Similarly, -1. If we take any point on the real line without -1, 1, same reason, this point also cannot be limit point of the sequence. So the sequence is divergent sequence. Okay, right. Let's see another example. Xn equal to n. Okay, where n belongs to natural number. Does the sequence convergence? Well, let's see the picture. The sequence look like 1, 2, 3, 4, so on. Okay. Let it is convergent to let this sequence converts to a number L. Okay. Then by Archimedean property, given any real number L, there exists n belongs to natural number such that n greater than L. Okay. But what does it means? If we see the picture, let this is L. If I choose an interval around L, then all terms of the sequence outside n, n plus 1, n plus 2. Okay? Are you getting my point? So, L cannot be limit point here. But I have taken L is arbitrary real number. So, any real number cannot be limit point of the sequence Xn equal to n. So the sequence is divergent sequence. Okay. Well, now let's see some more definition. Okay. If a sequence Xn converges to L, then L is called the limit of the sequence Xn. Okay. Here what is interesting thing? I would say the limit. Do I know there exists only one real number where a sequence can converges? Question. Can it happen? xn converges to L and xn converges to L prime where L not equal to L prime. Okay, is the question true or not? This is my question. Let's see the proof. Suppose there exist L and L prime with L strictly less than L prime. Since xn converges to L and xn converges to L prime, then what I try to do it? We try to get a contradiction out of it. Let's see the picture. This is real line and this is L and this is L prime. Okay. Here I take an interval around L. Since L is a limit point, then for all n belongs to capital N, xn lies here. That means after some stage capital N, infinitely many xn lies here by the definition of the convergence. Okay. Then if I draw a interval around L prime, then how many xn lies this interval? There are only finitely many guys. So I get an interval around L prime where there are only finitely many xn belongs to. But the definition of convergence, here for all n strictly less than n, finitely xn lies. Okay. But the definition of convergence says whatever interval around the number which you think is going to be the limit, then after some stage all the element of the sequence should be there. But there is not happening with L prime. But I say xn converges to L prime. This is the contradiction. That means if the sequence xn has a limit, then the limit is unique. Okay? Well, now the new notion, bounded sequence. What is bounded sequence? Let's see the definition. We say the sequence an is bounded if there exists m such that modulus of an strictly less than equal to m for all n belongs to natural number. That means if the sequence has supremum and infimum, then the sequence must be bounded. Let's notice some sequence which is bounded or not. First example, xn equal to minus 1 to the power n minus 1. This sequence equal to 1 minus 1, 1 minus 1, so on. Here the supremum of the sequence, supremum of xn equal to 1 and infimum of xn equal to minus 1. Since the sequence has supremum and infimum both, then the sequence is convergent. Since second sequence is 1 over n. We all of us know this sequence also bounded, because this sequence greater than 0, xn less than 1. Okay, so this sequence also bounded. We all of us third sequence xn equal to cos n, this sequence must be bounded, we all of us know. Last, see the sequence xn equal to 2 to the power n. We all of us know 2 to the power n strictly greater than equal to n by induction. Okay, so from this condition, this sequence is not bounded. Okay, well, my next proof is every convergent sequence is bounded. We say xn converging to L belongs to R, then we can write limit n tends to infinity xn equal to L. Since given convergent sequence, then suppose limit n tends to infinity xn equal to capital A. Now definition of convergence, take epsilon equal to 1. Okay, and n belongs to natural number. Then by definition we can write modulus of xn minus L strictly less than 1 for all n greater than equal to n. From this inequality we can write minus 1 strictly less than xn minus L strictly less than 1 for all n greater than equal to n. That imply minus 1 plus L strictly less than xn strictly less than L plus 1 for all n greater than equal to n. That imply L minus 1 strictly less than xn strictly less than L plus 1 for all n greater than equal to n. That means we can write two inequality involving absolute value. What is this inequality? This inequality is 1 0 strictly less than equal to xn strictly less than n plus 1. Second inequality is 0 strictly less than xn strictly less than, here modulus, here also modulus of L minus 1. Okay, well, and from 1 and 2 we can write modulus of xn strictly less than maximum of absolute value L plus 1 and absolute value L minus 1. Okay, for every n greater than equal to capital N. Okay, that means our sequence is bounded for all n greater than equal to n. Okay, now what happened before the point strictly less than capital N? There are only have finite number of sequence. Notice modulus of x1, modulus of x2 up to modulus of xn minus 1, and this is a finite set of real numbers. Are you getting my point? Well, that means it always have a maximum. Okay? Then we put this value modulus of xn strictly less than capital A for all 1 less than equal to n less than equal to capital N minus 1. Okay? And set m equal to, what is m? Combining these two relation here, modulus of xn strictly less than maximum of absolute value of L plus 1 and L minus 1 for all n greater than equal to capital N, and here modulus of xn strictly less than equal to a for all n greater than equal to 1 and strictly less than equal to n minus 1. Here the m equal to, say, maximum of absolute value of L plus 1, absolute value of L minus 1 and A. Okay? From this relation we can write modulus of xn strictly less than equal to capital M for all n greater than equal to capital N, and from this relation we have get, here for all n belongs to natural number. Okay? That means the sequence xn is bounded sequence. That imply sequence xn is a bounded sequence. Okay? That means every convergent sequence must be bounded. My next claim is convergent sequence always bounded, but bounded always imply convergent. Is converse is true? Just think, consider this sequence minus 1 to the power n. This sequence is bounded, I have seen. But this sequence also I have seen does not converge. This is a divergent sequence. So, bounded always does not imply convergent. Okay? Well.